Okay, so we're going to take a look today at a lesson about transformational functions, and it really is focusing on something you learned in geometry, which is that any shape can be made up of its vertices or vertexes, and those vertexes, if changed or made larger or moved, will create a transformation. So unlike in Algebra 2, where you learn about transformations based on functions, that actually will be our second lesson, we're going to concentrate on the idea that these 4 points make up a square. We're going to do translations, reflections, and dilations. Rotations, which is done sometimes in geometry, we will not be doing. So if you look at these points, these 4 points, -4, 4, that's this one, -4, -2, and then 2, 4, and 2, -2 make up the vertices of the square. And if I, again, do any of these things to it, it will move or reflect or dilate it. For the purposes of these notes, it's very helpful if you then go and fill in the left side with these values before I do anything. So why don't you hit pause and fill them in all the way until the back to number 5. Okay, so hit pause and do that. Okay, my assumption is you hit pause so that you could have these tables filled in. So in this first one is just asking you, hey, could you complete the translation in which you move x by 3 and move y by 2? And we have to remember something special about translations. And translations are going to actually, we write them like this, but they're technically in parentheses. And so this will actually occur in the opposite direction. You remember maybe from other things that, for instance, when you find a 0, for instance, you would have to set this equal to 0, and that actual translation is actually -3. So that's actually going to move the graph left. Okay. And if I set this one equal to 0, it's actually going to move the graph right. And you may ask, well, why are we setting it equal to 0? Well, the idea is, this is going to move the graph up. So x is going to move left or right. And so this one's negative, so it goes left. And this one is going to move it up or down because it's y, which is the y-axis. So this moves it up. And you might say, well, why is that happening? Why are we doing that? And the reason we're doing that is because of the fact that this graph, right, is going to reflect, it's going to do everything from the origin. So if we set the x and y equal to 0, we're actually seeing what these equations are going to do in correspondence to that. So what you do literally is you just come over to these points, and you might have been able to move the graph of geometry. So you might have been able to just move these points, and you really are just going like this. You're just going left 3 up 2, left 3 up 2, left 3 up 2, left 3 up 2. And that's perfectly allowed, but you can also do it algebraically, right? If this value is actually -3, and I come over here and subtract 3 from all of these, that will give me my x coordinate. So that would be -7, -7, -1, -1. And then if I take the y coordinate and I move them up 2, so I add 2 to all of them, okay, that would give me 6 and 0 and 6 and 0. And so as you can see, if I were to translate these in this direction, my new coordinates, let me get my new coordinates would now be -7, so right about here, and then up 6, right? My next one would be -7, 0, and then my next one would be -1, 6, and then -1, 0. And so if I just simply connect those dots, I have my rectangle, and it has been moved in the exact idea that we want to move it, left and up. Okay, so now it says reflect the same figure over the x-axis, okay? And so to do that, right, what it's asking you to do is take the original graph and reflect it over the x-axis. Now, what that means is you're actually going to make the y coordinates negative. Now, you may say, well, why is that? Because if I reflect over this axis, what happens is these two dots will go over the y-axis and these two will go over the y-axis, but I'm actually changing the y values to do that. And so if I come down here and multiply all these by a negative, right? Then I would get only change this one. So -4, +2, -4, +2. Notice I didn't change the x's in here. And so when I graph these new points, let's take a look at what it looks like. Okay. You can see I still have a square, but now my square has reflected basically, and I'll show you the original graph. Basically, these points that were 4 high above the x-axis, they're now below. And the ones that were 2 below are now above, reflecting it again over the x-axis. So you might be able to figure out what this means. If I want to change the y-axis, I actually will change these. And I'm actually going to divide them. This will make more sense in just a minute in the next video. So I'm going to change these by dividing by -1. And then what happens is this will be 4, 4, -2, -2. And these will not change because if I'm going to reflect over the y-axis, I don't change the y's, which sounds counterintuitive. I'll review that in just a moment. I just want to show it to you happening, and then I think you'll be able to understand what I'm doing. So, okay. Okay, you can see now, if you look at the original graph, that these that were 2 over here and 4 over there, they have switched positions, and that reflected over the y-axis. Now, the reason this is important to understand is reflections occur, and listen to me very carefully about this, reflections occur based on what you do not change. So for instance, notice I changed the x, reflection occurred over the y. And here I changed the y and the reflection occurred over the x. It's very important to remember that. Reflections occur over what is not changed. Okay, so 2 more ideas here. One of them is dilating a figure by a scale factor of 2. Now, interesting, a scale factor back in geometry days meant everything. Okay, so in algebra, we're more specific. We'll say dilate over the horizontal values. But in geometry, if we dilated this based on a scale factor of 2, that literally means just multiply everything by 2. And that's going to make the graph basically just 2 times as large. In algebra, this is called a horizontal and vertical shift. And we're going to talk more about that in later videos. I'm just kind of reviewing some of the things you learned. Okay. All I'm doing is multiplying them all by 2. Okay, and if I graph these dots, you'll see that same square shape, but it'll be twice as large in all directions. Okay. I made a little boo-boo. Let me fix it. There we go. You might have seen it. It's +8. There we go. All right, and you can see that that is the same square, but it has now been dilated, meaning made larger. And you might remember that word because if you've been to the eye doctor, dilating your pupils means they're going to make them bigger so they can look at the internal structures of your eye. But dilation also can mean making something smaller. So if I multiply everything by a half, scale factor, right, it's going to make the entire thing smaller. And again, scale factor is a geometry term, and this is going to be an algebraic lesson in just a couple of minutes. And so again, what's happening here is that these values, you can see they're all algebraically becoming 1/2 of what they originally were. So dilation is a confusing term for some students because they've heard the word from their eye doctor and they think it always means to make bigger. Dilation can mean to make bigger, or smaller. Also notice the spelling of the word because it's pronounced dilation, but it's spelled dilation. Just an interesting little fact about English there. So as you can see, this is the same square we saw originally, but it's now half of its size. So that's a review of some of the things you learned in geometry. Now let's review some of the things you learned in algebra 2. Okay, so for instance, if you have x plus 3, right? That value will actually move the graph to the left. And so you can see that right there. And you may be saying, wait a minute, Mr. King, why did you make this the same? And the reason is in some other places in the world, again, this would move it up, but you're like, hey, what's going on here? And the reason is in some other places of the world, that value is actually put over here with the f of x, and it looks like that, right? With a plus on it, which, is going to explain that to you. But over here, right, we've moved it to the other side. So it's kind of interesting. If you see it like this, you would set it equal to 0. But in algebra, which is what we're going to focus on, that value, you look directly at this. Okay, so let me show you what I mean. So we're looking right at this value. And remember, it was over here as a plus, and now it's moved over here. So this one is going to do exactly what it says. And that may be confusing, but not if you've taken algebra 2. Basically, this changes. So this one right here is going to always change to the opposite. You can see I already wrote that in here, opposite h, where this one will stay the same. Okay. And that's actually important to realize about all y coordinates. You'll see a little conversation about that in a moment. So when you reflect, you have this value right here, right? And that value right there is going to multiply your y values. But you see how this one's inside the parentheses? So this one is opposite, right? We whatever it is, we do the opposite. So this one's kind of interesting. It's inside the parentheses too. So it looks like we multiply like this one, but actually, believe it or not, this one over here is a divisor. Okay, and we'll see more about that soon. So this one right here, if it's inside the parentheses, that one right there is actually going to be a multiplier of 2. So we'll talk about it soon. This will multiply. And so with this, okay. So this thing up here that we said as a scale factor of a half, if I wrote it in algebra, it'd actually have to be like that. And we'll get more into that when we look at some algebra examples. But that's important to have in your notes and have understood. Multiplying works perfectly on the outside. So again, notice what's going on right here. This is multiplying, but this is actually dividing. And so that's what explains why this is multiplying, because you're actually dividing. Let me be more specific. You're actually dividing by 1/2. And when you divide by 1/2, it will multiply by 2. Okay, a little bit more general information here is that this is always opposite of h. The reflection is always going to be, if you have a negative reflection over the y-axis, is if you change x. Remember what I said. You change x, it reflects over y. In the dilation, right, this one again is a divisor. There are some interesting notes in here that you've probably seen before, but basically what I said is true. Now this is saying right here that if b is big, because it's dividing, it's going to do the opposite of what you think it will. Now over here we have this k, and it's like, why do we use k in math? And I just kind of mentioned that this word is from German, constant or constant, and that's why it's a k and not a c. And that is exactly the same as you see it. So that one's the same. Whatever you get, that's where it's going to go up or down, where h, again, opposite. So it's going to go the opposite of what you see in here. This is a multiplier, as I just mentioned, so that's not going to change. Whatever this number is, I multiply by it. So if it's negative, it's changing the y's to be negative, reflecting over x. And if this, whatever this number is, I will multiply it. So if I multiply by a fraction, it's going to make it smaller. If I multiply by an integer, it's going to make it bigger. All right, thanks. That's our first lesson, and I hope that it went well, and please feel free to rewind or listen to it again if you need to.